Hello everyone. Before starting the lesson, try the warm-up. Use Desmos to graph the following functions. f of x equals negative 5 times x plus 3 in brackets squared plus 5. g of x equals negative 5 times x plus 4 in brackets times x plus 2 in brackets. What do you notice? So take a minute, graph these two functions, and see what you notice. If you graph them successfully, you will notice that they both give the same graph. So f of x is equal to g of x. That's what we should notice. And this leads into our lesson today, adding and subtracting polynomials. Our goal is to determine whether polynomial expressions are equivalent. So we need to first know that a polynomial expression is an algebraic expression that involves more than one term. Poly, the prefix poly means many. Nomial refers to the number of terms in an expression. So you have many terms in the expression. We're going to add and subtract polynomials to determine whether or not they are equivalent, the same. So here's my first example. The question is, are these functions equivalent? I have a of t and b of t. They have different looking equations, and I want to know if they are the same on a graph. Well, I don't actually have to graph. All I have to do is know this. If a of t equals b of t, if the functions are the same, then if I subtract one from the other, I should end up with 0. That makes sense because, for example, I can say 3 equals 3. Well, if I did 3 minus 3, it would equal 0. So it's the same with functions. If the functions are equal, if I subtract one from the other, my answer should be 0. So how do I subtract one function from the other? Well, this is what I want to do. A of t minus b of t. Well, a of t is this, negative 5t squared plus 100t plus 1,000. And I'm trying to subtract b of t, which was negative 5t squared plus 75t plus 1,200. So this is what I'm trying to simplify. Really, I'm just simplifying this expression. So when we simplify an expression, we want to get rid of any brackets and then identify like terms and then add and subtract the like terms together. So let's start with the brackets. I'm subtracting each term inside the brackets. So that subtraction symbol, the minus sign, applies to each term in the brackets. So when I do that, I end up with a double minus, which simplifies to plus. Minus plus is minus, minus plus is minus. I end up with this expression. Now I have to identify like terms. So just remember, like terms mean they're either both constants, like 1,000 and minus 1,200. Those are constants. There's no variable part to those. Or if there is a variable part, they have to have the same variable part. So t and t, those are like terms. T squared and t squared are like terms. So if I look at my like terms, I have negative 5t squared plus 5t squared. Well, that is 0. 100t minus 75t, well, that's 25t. And plus 1,000 minus 1,200, well, that's minus 200. Now, these are not like terms. This has a t, this does not. So I can't simplify this expression anymore. So then I have to ask myself, are these functions equivalent? Well, if they are, remember, when I subtract one from the other, I should get an answer of 0. I did subtract one from the other, and this is what I got. Is that 0? No. So this means that a of t does not equal b of t. The functions are not equivalent. Here's another example. Are these functions equivalent? So here I have c of x and d of x. We're going to do the same thing to see if these functions are equivalent. We're going to subtract these two polynomials and see if we get 0. If you want to work ahead and try this on your own, pause the video and try it. here's all my work. What I did was I took c of x, wrote it here, and I'm subtracting d of x here. Notice I put d of x in brackets because I'm subtracting the entire function, not just the first term. I notice that I have an exponent of 2 here. Remember what that means. An exponent of 2 means you're multiplying the base of the power by itself. In this case, x minus 1 is the base, so it's x minus 1 times x minus 1. If you forget how to multiply the brackets out, this x gets multiplied by that other x and the minus 1 times x, and minus 1 times minus 1. That's where these came from. Now I still have that 2 in front of the brackets. Each term in the brackets is multiplied by 2. So 2 times x squared is 2x squared. 2 times minus x is minus 2x. 2 times minus x is minus 2x. Those are like terms. Minus 2x is minus 4x. I just simplified in this step right here. Then I did 2 times 1 to get 2. On the other side, I'm adding 3x. I'm adding negative 2, so that's minus 2. Over here, I'm subtracting 2x squared, so minus 2x squared, and I'm subtracting minus x, so that's plus x. Once I notice all my like terms, I put them together, and they all cancel each other out. 2x squared minus 2x squared is 0. Negative 4x plus 3x is negative 1x. Plus x, well, that's 0. Plus 2 minus 2 is 0. So the whole thing equals 0. So because c of x minus d of x equals 0, that means the two functions are equivalent. They will give you the same graph. With this next example, we're doing the same thing. We're trying to find if the functions are equivalent. So I'd like you to pause the video and try this one on your own. Here's e of x, and I'm subtracting f of x. Get rid of the brackets by expanding. 2x plus 4 times 2x plus 4 simplifies to this, but I'm subtracting the whole thing. So that's where I get minus 4x squared minus 16x and minus 16. When I find all my like terms, I notice that they all cancel each other out. I end up with 0. So because I subtracted my functions and I got an answer of 0, that tells me that the functions are equivalent. Now here's a challenge problem that's kind of off the wall. We haven't talked about trigonometry at all, but this is talking about a triangle. A triangle has side lengths x squared plus 1, that's one side length, x squared minus 1, that's another side length, and 2x, that's the third side length. And we are to prove this is a right triangle. Now I'm not going to give too much away, but you can try this, see what you come up with, and then I'll come back and give a hint if you need it, and then I'll give you more time to try it. So pause the video, see what you can come up with, and check back in. If you need a hint, here's my hint. If a triangle is a right triangle, it will fulfill the Pythagorean theorem, a squared plus b squared equals c squared. So maybe that will get you thinking on the right track if you had some trouble earlier. So you can pause the video again and try this. If I square all the side lengths, I end up with these. And then I notice, well, if I add this and this together, the like terms, negative 2x squared plus 4x squared equals 2x squared. So if this is a squared and this is b squared, when I add them together, I get c squared. So a squared plus b squared equals c squared. It fits the Pythagorean theorem, therefore I can say this is a right triangle. All right, so you've been shown how to determine if functions are equivalent by subtracting, and if it equals 0, then you know they're equivalent. And now it's time to practice. If you have any questions, please reach out.